So I found out that a kind of average UK practice is 3 people, which means that there are a lot of kind of single practitioners, and then there are us, which is about 180 people, and then you've got the kind of Fosters, who are about kind of 2,000 people. So we sort of sit in the middle, and I guess a lot of you will be thinking about what kind of practices you're going to go into. And a lot of focus is on the kind of front end and the concept design and winning work. But actually, if you work in a bigger practice and you do these big projects, a lot of it is about the collaboration and building relationship with manufacturers, and there are a lot of people to please and stakeholders. And actually, the more successful you are at building those relationships and working together, I think the more kind of complete your architecture is. So that's why I kind of chose this, given a complete free reign of topics. So I'll give a brief introduction to Make, and then I'll talk about 3 case studies of different kind of approaches we've taken. If you're bursting to ask a question, please interrupt. It's not that formal. So I've got a kind of small clip. I don't really show design professionals. It's more just something we do to clients to show our approach, but it's a kind of 90-second clip. I don't know if the sound will work, actually. If it doesn't, we'll skip past it.
Make has one purpose: to design the best buildings, places, and spaces in the world. Something many dream about, but precious few deliver. Because achieving the best is not about formulaic styles or off-the-shelf solutions. It's about having the curiosity to explore the unique and full potential of every opportunity, and the conviction to bring the best solutions to life. That's why at Make we'll never dumb down, cut corners, or reach for the cookie cutter. Instead, you'll work with a truly passionate, empowered, and accountable team of makers, united by their desire to research, explore, design, and deliver the best. In a unique studio created to attract, inspire, and liberate the very best talent, where all makers are owners, all opinions matter, and all clients and industry experts are welcome collaborators. All working together to find the best answers to 7 questions. What is best for the site? What is best for people? What is best for the environment? What is best for the client? What is best for the investment? What is our best ambition? And what is our best legacy? These are the 7 key questions that drive us and make us who we are, that provide a consistent framework for inquiry for everything we do. Questions we know will inspire, provoke, and contradict in equal measure. Yet questions we will always commit to explore and resolve for every project, because they demand we make the best architecture in the world.
This is our home in Fitzrovia in central London, and we had this great office, and then it became terribly expensive, and Derwent, our landlord, said that they had this old NCP car park that we could use. So we fitted it out, and this is the entrance ramp, and we put a lovely ETFE roof over the top, put all of our sort of 3D printing and our breakout spaces here. And so it's kind of a pretty kind of cool, big central London space. So that is our home. And on the wall, we have this kind of mission statement, and that our purpose is to design the best places and spaces in the world. I know it's ambitious, but it's sort of what we believe, and we've all signed up to this charter on the wall to kind of illustrate that. So we are under here. We've kind of kept this industrial aesthetic, exposed M&E. A lot of the work we do now is for kind of these big tech employers, and they love this sort of exposed aesthetic, partly because it reminds them of the San Fran warehouses where they all started, but also you can kind of move and adapt, and it's quite flexible in space in terms of how you move things around and organize it. We now use a lot of like VR and CAD/CAM and 3D printing. I noticed Ainsley was showing me some new machines that you've got, so we use all of those new techniques, but actually drawing, sketching, modeling, all of the traditional kind of tools as well are still kind of very important to us. We work across like a range of scales. We've done a master plan Elephant and Castle that's taken 20 years. We do spoons, drinking fountains, private homes, university research buildings, kind of a full suite of kind of sectors. And I think that is this sort of old Heatherwick thing about ideas scale, you know. So make sure you kind of get involved with everything you can. And actually putting people at the front of everything, so the stakeholders, the people that live there, making it economically viable to the people that are going to kind of use the space. And there is a lot of talk of kind of placemaking, and that is this buzzword. But actually, I think we view that placemaking is just a place where people choose to go when they don't have to be there. And what are the kind of dynamics behind those spaces? We do quite a few different buildings. This is sort of university buildings. We've done the handball at the Olympics, UBS headquarters. I've just come back from running our Beijing office, so these are some Chinese projects which are especially kind of dear to my heart. And also lots of kind of interiors. Just make them kind of vigorous, exciting places where you want to be. And I think be quite bold with the moves you make, certainly for the interiors. So like I say, offices, residential, mixed use, big things in the city, and kind of schools. So quite a kind of diverse portfolio of work. 3 continents sounds terribly grand, but we've just opened a Sydney office, which is small but doing quite well. And we have 23 projects on site, which is kind of exciting to us because our average age is 33. So you've got all these really young teams going onto site, learning how to build, and all that knowledge is kind of fed back into the company. So it's kind of a bit, ambitious, but actually, because of the kind of hierarchy of our office and this kind of employee-owned element, people are encouraged just to kind of run and take on projects. So we've got lots of awards, but mainly just to say that we've won the kind of best Sunday Times best kind of employer workplace awards, and that kind of means that we get the best people, everyone's happy, they're sort of fulfilled with the work they're doing. It's not a kind of artificial thing, and it's sort of genuine feedback that I think makes us proud. So how we work, we generally take a view and make a move, and that is often divisive, but certainly kind of engenders debate. And I think that's sort of where we want to be, because this is an opportunity to have discussions about the environment, placemaking, people, money. So sort of Ainsley touched on this. We think to deliver brilliant architecture, you've got to kind of work well at home. I always think if you listen to terrible music, you can't really draw very well, and I think the same is true of our business. So, we're employee-owned. That means that we have a single share that is held in a trust. So we all have a kind of share of that business. So when we do well, the profit shares are shared amongst everybody. When we win a project, everybody's delighted. If you're kind of, if you're a bit light on your workload, you're more likely to kind of pitch in and help with someone else's work. I think it means that we don't travel first class and use taxis, because every time you're kind of spending money, it's money that you're taking off your colleagues. So it's a sort of balancing act. And I think from that kind of egalitarian approach, a kind of consensus-based decision-making evolves. So I think it sort of starts kind of with the concept. Let's get a bit of water. And another sort of string in our bow is a sort of independent think tank. There was this feeling that we should be doing things which are beyond just our sort of immediate commissioned work. And this is to sort of, chaired by Ken, which some of us sit in, and we get kind of philosophers or urbanists or different types of professionals to feed into it. And we research these kind of white papers which we present to government or anyone who will listen. But the first one was about the future of the high street and how that's going to evolve and all the challenges that faces. And that came up with a lot of interesting ideas which we were then able to kind of feed into our projects in real time. And the second one was about vital cities, not garden cities. How do you deal with this housing crisis? It's terribly complex, and there are lots of different things which are going to have to happen to not quite solve it. But one of our kind of big beliefs is that you need a degree of density. I used to live in Hong Kong, and I think it's a very sort of successful city. You have this high density on transport nodes, and you get rid of the car as much as possible, and you remove this sort of sprawling town where everyone has their own space, and you put people a sort of a short commute from where they need to be. But that is under development, and certainly in China, they have slightly more opportunity for that than here. And so we kind of clustered these cities into global cities, which were New York, London, and Hong Kong. Mega cities, which are Beijing, Mumbai, and Sao Paulo, green cities, car cities, so that you're not sort of comparing apples and bananas, you're comparing like for like. And then we've commissioned this research, and this has become a kind of database of cycling commutes, quality of life, all these variables, which you can now put into this sort of algorithm effectively and create comparisons and try and draw information from, and from that understand what the kind of the challenges facing us are. I'm not going to talk about it today, but we've just launched a student competition for the Future Spaces Foundation. So if you go to the website and have a look, there's a kind of lots of data, and I think that's kind of what we're trying to explore now. We've got all this information. How can it be utilised, explained, exposed? So if you want to get involved, please be my guest. So architects and manufacturers, I'm going to look at sort of 3 case studies where we've had quite different but strong relationships with our manufacturers to help deliver these buildings. One is a straw bale building we did for Nottingham on their campus, which was a research facility, a stainless steel clad building in the city, and then a kind of light pipe product which we developed kind of in liaison with the contractor. So this is Nottingham. It was so it's an agricultural campus, and this is our building kind of in the middle. So it's obviously surrounded by fields, and the research which is going on in the building is about how to use kind of high-tech systems to enhance agricultural produce and productivity. And we kind of thought, well, how can we do something similar? So we use a kind of high-tech approach, but with a very traditional building materials. And we were just talking with Matt before about mod cell, and this was kind of a mod cell product. I see you've got sort of some exposed in this building. So this is what they were kind of offering. So sort of at its fundamentals, it was a kind of wood, straw, and lime render. So these are very sustainable and renewable materials to have as a kind of starting point. And then a lot of our research into sustainability is about like transport and how far it's coming and all of the kind of carbon miles associated with that. And we thought, wouldn't it be a kind of neat circle if we could just take the straw as a kind of byproduct from the adjacent farm, try and kind of manufacture something on site and deliver it as a sort of very kind of simple, holistic life cycle. So we then developed our own cladding system, which was sort of like the mod cell system, but we extended it to 14 meters, tried to do a kind of commercial application with it, just the way it was kind of having to be engineered slightly differently to achieve the height. And then in the south elevation, slightly denser so that we reduce the amount of heat the building's taking on. And on the north, just kind of expose a bit more, get a bit more light into the research building. So this was our sort of theory. So we rented a barn down the road from Nottingham and used it as a kind of manufacturing hub. Each of these cassettes is sort of governed in size by the size of 2 straw bales. So in fact, the kind of proportions is governed by, the thrashing machine that collects and then binds these bales. But it's as good a generator of form as any, and so these kind of dimensions were what defined it. And then they were stuffed sort of into these pallets, and then kind of prefabricated in this controlled area. So it was sort of some of the qualities of a prefab in a kind of field laboratory, as it were. And these were craned into place and erected, and the whole process of this only took 6 weeks, which for us, we were astounded by this because cladding is normally one of the most kind of labor intensive. It's got the longest lead in time, huge amount of time to kind of install it on site. So we were really pleased to see it go up so quickly. And this is sort of time lapse of them sort of stuffing it. So each one gets 2 cassettes. They then kind of finish the coffin and wrap it in the waterproofing, seal it, and then crane it up. And actually, you can kind of manufacture them as they're going on site. So you're not waiting for a kind of the complete process to be finished before you can start putting them on site. And as you'll see in another project I'm talking about, these huge scales of cladding means that you're talking about sort of a lead-in time of 3 years from concept to delivery. So having something sort of as straightforward as this made everybody kind of sing, really. Yeah, and that was the sort of completed building at Nottingham, which is up now. So for the second one was this stainless steel case study. So UBS were a big bank and came to us and asked for us to kind of consolidate a lot of their offices from around this area of Liverpool Street Station. It became quite a political project, this, because there was Peter Foggo designed estate, and it was our belief that actually the City of London shouldn't be the Tower of London and kind of ring-fenced, and these offices were no longer kind of fit for purpose, and people didn't want to rent them. And so with the city and with the planners and with UBS, we developed this idea of a cast concrete block. It sort of mimics the sort of financial stability which UBS want to project, but also this idea of this single strong unit. And then we would carve out where we were introducing atria, terraces, public realm, and sort of express those into the side of the block. So one of the elements of the brief was to have these huge uninterrupted floor plates so that you can have 6,000 people in the building, a trading floor plate of 2,000 people. And for that kind of density, we pushed all of the cores to the edge of the building so that you've got something the size of the Emirates football pitch in the middle of the floor plate. And that meant that we could use the cores to express the outside of the building. So express where the stairs were, express the vertical movement, kind of delineate where the offices are. And that's kind of where the sort of external expression came from. So looking at the cladding, we looked at a kind of anodized aluminium finishes and stainless steel. I think aluminium, I don't know, most of the work we did in China, it was probably the most popular building product there. It uses a high amount of energy, sort of developing and manufacturing aluminium. I know that Iceland has a huge aluminium industry, and it's not because they have any of the raw materials, it's because they have such cheap power from all the sort of volcanoes and geysers. So actually people ship all their materials there, manufacture the aluminium, and then ship it off to where it needs to go in the world, which is, when you think of the sort of Nottingham building life cycle, you can see kind of what's wrong with that. Stainless steel is entirely recyclable. It doesn't lose any of its properties, no matter how many times you reuse it, which means that you've got to design with it in a way so it can be recycled and not stick lots of sort of other products to it that don't come away easily. But actually, for us, it was quite an easy choice to go with stainless steel. So we began to kind of look at that whole life cycle of steel from the melting to the electric furnace. Some of the steel would have been pre-used, some not. The casting, hot rolling, the heat treatment and cold rolling, the cutting and finishing, and then the fabrication. So sort of in the same way that the size of the pallet had been governed by the size of the straw bales, we looked at what the optimized panel height could be from this manufacturing procedure. And actually it's these 1,500 meter height rolls, which is what comes out of the foundry. So that actually became a driver so that we wasted as little as possible of this material. And then it would be bent and formed into these panels in the top right-hand corner. But the problem we found, this is a German manufacturer called Sealy, by the way, and I should say they were incredibly helpful and very pro development. And we had this great relationship with them, and every stage of the process, every time we came across a problem, they were very open about the challenges they faced, and sort of invited us to get involved, which was really great. But as you can see, there were 6 guys trying to fold this one panel, and we need 3,000 of these panels, so it's going to take them a huge amount of time. It's not a very kind of efficient way of doing the work. So one sort of example of how we worked together was to design this jig so that two people were able to manipulate all of the panels and fold them and massage them into position. So sort of slightly streamlining the process. So we then got lots of different types of finish, and we developed all these samples together, different patterns where we wanted to express on the reveals so that it felt kind of bitten into this building. And you can see the big 6-meter panel at the back. I mean, slightly we didn't know where to put them, so we put them in reception and became well, this is our old office actually, but became this sort of display. And actually it's one of the ways of getting people to talk about the process and share some of the knowledge you've got working on these projects. You know, it kind of gets everyone's attention if you stick it in where they're meant to be collecting their post. So a little bit technical, you know, we found the challenge here are if it's very smooth, it doesn't sort of disintegrate as well, it doesn't rust as much, it's just much less prone to kind of the grit that is in an urban environment. But equally, the less smooth it is, the more robust it is in terms of picking up scratches or like sort of, so you can't see the scratches, how easy it is to kind of knock when you install it, and actually it's quite a forgiving material. So it was a bit of a balance between something that was going to last for 50 years or more and something which was going to kind of look really good from day one. And then the kind of finish we decided to go with was this sort of linen, and these are one of these big rollers that they pass over the steel. And this was developed again with Sealy to work out kind of exactly what we wanted. And then this is your sort of final linen finish, as it was called, a kind of optimized relationship between something that was smooth enough to kind of perform in terms of, you know, any damage to the material, but also slightly forgiving to getting it on site. So it's still quite shiny, and so this is a bead blasting machine that they have in their factory, and each of the 3,000 panels would be passed kind of through that slightly to make it less shiny. We'd initially sort of conceived it as this incredibly shiny metal building, and the planners felt that it was too shiny, which I think they were right. And so the bead blasting helped to just kind of make it a little bit more matte, tone it down slightly. So that's that process. And then endless rounds of inspections. And again, to be fair to Sealy, they encouraged us to come and visit, and we were quite critical, and we came back again and again and again, and ultimately we did kind of get the result we wanted. But endless different coil numbers with different finishes and different spec. And we actually suggested this kind of honeycombing system, which you've kind of seen in other types of packaging. I know some Amazon packaging is a bit like this, and it's sort of this obvious moment when your Amazon package arrives and you think, why don't we just do it like them? And because it was a completely new product, we had to then work through a kind of testing program with them and just working out exactly how sort of strong this really was. And then this is my sort of client creepily stroking the final panel with delight, knowing the amount of kind of effort that we'd put into getting there. So we finished our panel. We've mounted it and onto these kind of mock-ups just to see how the various elements fit together. So I appreciate some people won't pay for mock-ups, but if their buildings are a certain scale, it's really terrific to do because it forces you to detail the building and test all these details way ahead of where the actual building is. So you test all your floor interfaces, your cladding details, and actually it pushes you to a kind of contractor drawing, and then anything you see or anything which doesn't work or anything which doesn't feel right, you've got time to put back in. It's sort of stage 2, which is great. So then these mock-ups turned into big kind of prototypes for testing, and again this was all in Germany. And it is quite fun. You go into the yard there and you see sort of, you know, a Zaha system over there and a Foster system over there, and you get these kind of weird snippets of like buildings which are going to appear in our lives in the future as they're sort of tested. And these are sort of real mock-ups. So the idea is to then test these as products. So they have these huge old aero engines, and they drive kind of wind and rain and things at them and see how they perform. So I've got our other geeky testing videos that I quite like to watch. So then they blow this wind and they rain, they see where the ice forms, how the ice forms, where the sort of problem areas are, how you would then maintain the building after you've had one of these huge storms. And then they throw a huge amount of water at it and see how it would kind of cope in typhoon conditions. We did sort of mock-ups to see what the optimum height of a pigeons feel most and least comfortable in, to make sure that it didn't become a kind of lovely place for them to sit. And it was quite fun sort of making these things and then waiting for the pigeons to come and seeing which sort of runs they were going to make home. And then sadly not making them like that. But if you ever want a kind of the optimum dimensions for a ducat, you can find it out. And then I think during the kind of construction, there is going to be an inevitable amount of sort of knocking and stress testing, or kind of kamikaze pigeons that are going to fly into the panels. And this was just a way of saying, you know, is it going to dent and bruise? And I'm not sure what this is testing for. I think it's like a kind of window cleaning gantry thing from a BMU banging against it. But I think they were really kind of driving home the point that they'd spent all the money on honeycombing and it was going to be kind of very robust. So yeah, and then it was kind of fully installed, and actually did have this very sort of universal finish. And you do generally see this kind of checkering effect on cladding buildings, and you don't see that. And I think that's testament to the cladding contractor and sort of some of my colleagues as well, and how kind of doggedly they kind of followed this. But it does come at a huge timeline. I mean, you know, most of you will probably do a degree in the process of that. You know, from getting the samples in the beginning of 2011 to starting the fabrication process in October 2013. So certain types of projects lend themselves to this, but you don't get to do it again. And once it's up, and you drive past it every day, and you're an architect, you would regret not having done this work early. So this is the sort of the whole process of making the steel, just sort of put together. So it's 240 tons of stainless steel, which is actually 4 of these, which are 20-ton kind of blocks, which come out of the foundry. And then they're hot rolled and then cold rolled afterwards. So each time becoming slightly thinner. So when it's hot rolled, it comes down to a 5 mil, and then it's rolled again down to 2 mil afterwards. And it is amazing. They are amazing places, these foundries. If you ever get a chance to kind of go and see them and work with your manufacturer, I highly recommend it, because they've got so many sort of ideas and so much expertise about how to do it. It's sort of almost the first place you should go to kind of answer your questions. Yeah, so those are all of our rolls. So we needed 3,000 panels in the end. This is the bead blasting. So you choose the sort of size of your beads as well. I mean, every part of this process is tweaked to get the product which you want. And then it's kind of folded into shape on the jig, which we showed. And that's the honeycomb going in at the back. So each one of those coils has about, I think it's 300 meters. I think this is the last panel going into place on the day off. So that was the final finish, and they started trading in it about 10 days ago. So I'm just keeping an eye on the time because I know you've got to get the last one is quite quick. It's about developing a kind of product with a manufacturer, and I just want to look at a light pipe as an example. So it's a sort of kit of parts, which are things which manufacturers already make, but if you can make your own, then that's a sort of exciting for both parts. So if you look at the kind of simple element of the light pipe, we found that the big constraint was the polycarbonate dome at the top, which is vacuum formed and 1.5 meters wide, and that was a sort of immovable proportion. So we took that, and at first we just stuck them in the handball arena, but this is it in kind of legacy mode, being used as a sports hall. But actually we just had very stripped back, bare light pipes as they kind of come, and that was because it was a very economically viable Olympics, and this is just a small example of kind of where that constraint was shown. But then we sort of wanted to optimize how much light is coming into these sort of typical light pipes. So we developed these kind of scoops to really distribute as much light as we could kind of internally. Again, you will find your clients want to use as few specials as possible, just good, honest, generic products that are kind of cost effective, but then you can kind of magnify their effect with some sort of small design principles. So we were looking at kind of exaggerating these scoops and kind of optimizing what the light pipe could do. This is a building in Nottingham which physically bridges the university and the business park, and it's for a kind of incubator for startups which have come out of the university. So we kind of straddled that road, and we were originally planning to do this triple height atria. But we wanted it to be naturally ventilated, we wanted it to be quite cheap, we wanted it to sort of be very low maintenance. And so we swapped out this kind of rather slightly too expensive window system in the roof and introduced the light pipe. But we wanted a bit of natural ventilation in the summer, some mechanical ventilation. So we were able to introduce, working with the manufacturer, this kind of ventilation system which was integrated into the light pipe. Again, typical standalone product, keep our scoop at the bottom, buy a kind of kit of parts, and then insert a heat reclamation unit, which ultimately kind of ended up working really well. And if you develop a product with a manufacturer, then they're free to sort of sell that capital knowledge and the product again further down the line. So they're kind of as interested in working with you on this as you are. So then, we cast into the concrete these big scoops, again, retaining some of the kind of ideas we'd had in the previous projects. And then we have the kind of product installed, and it's really low maintenance, pretty cheap, really energy efficient for the building. The university were delighted, and it ended up having a rather simple but kind of smooth impact. So a kind of slightly more refined on where we'd started with the handball arena kind of 4 years previously. In Broadgate, we also had a kind of these amenity spaces which we wanted to light. We wanted to use the principles that we'd already worked with, except that we were really trying to drive out the wet trades because it's risk, and it's messy and it's slightly unpredictable. So anything we can prefab off-site and bring on, they were really keen to do. So we wanted to use all these sort of things we'd learned about this light pipe, but as a sort of prefabricated version as a kit of parts. Came up with all these different ideas and configurations, and then ended up with a kind of, what ended up being quite a complicated system, in fact, but with these typical parts, these kind of mechanical louvers, the polycarbonate dome, and these sort of ribbed domes on the bottom. And I think what was quite good, again, is that the Germans wanted to destroy it because they wanted to test how long it was going to last. So we built these mock-ups and did sort of incremental weight tests to work out just what kind of forces could be applied to it before it failed. And once we were happy and convinced with both the rain and the pressure, we went and built these kind of, we didn't have to make mock-ups or prototypes because it's a prefabbed element, so you can just make it off-site, test it, look at it, and then install it. And that's preferable to your client because they're not making two products. You know, they're not making one and then throwing sort of wind and rain at it and then building it again. And then it was installed afterwards. And I think what was really successful about this is that this concept of this kind of machined block really kind of came through by these sort of fittings, like driving through that look like these huge kind of screws that come into the machine. So although detail, actually quite effective in sort of finishing the concept off. And that is now where it sits next to the City of London. Anyway, I know I've got to finish by 2. Thank you very much for your time, and if you've got any questions.